Howdy, welcome to Lab 4. Before we get started, please make sure you finish Lab 3 and the multiply IP in your Lab 3 works correctly, because in Lab 4, we will incorporate this multiply IP into our design. Okay, so for Lab 4, we're going to boot a Linux system on our Zybo board. If you're not familiar with Linux system or concepts related to operating system, I recommend you to go to eCampus and download this set of slides. I believe it's called Introduction to Linux. You can see the definition of kernel here, which is basically something that provides basic services such as interrupt handlers, schedulers, memory management in the operating system. So this is like the major part of an operating system such as Linux. And I also recommend you to refer to this picture so you can have a better idea of how Linux kernel interacts with the underlying hardware platform and also your user programs. Okay, so in this lab, to boot Linux system on the board, we need to create 4 separate files, download them onto an SD card. Then we will insert this SD card into the board. Afterwards, we'll press the reset button and the system should boot on the Zybo board. So the 4 files are zinc boot image, the kernel image, RAM disk, which is a temporary file system, and also the device tree block, which contains information of the peripheral devices that we need. Okay, I would suggest you guys to read this system overview carefully so you have a good idea of what we're doing in this lab manual instead of just following the lab manual blindly. So as you can see, the processing system is really similar to what we did in last lab, except that we have a few extra peripherals in the processing system. So in the first part of the lab, we basically do what we did in lab 3, except that when we create the block diagrams, we select these peripherals for the processor instead of just UART. And this is pretty straightforward. In the second part, we will create a bootloader. So what does the bootloader do? It basically helps loading the kernel image from SD card to the memory on your board. So to generate this bootloader, you use cross compiler and some configuration files which are included in these commands. And then you need the help from SDK to generate this boot image. So this is also pretty straightforward, and you can just follow the lab manual. In the third part, we will first compile the Linux kernel image. And this part will take a pretty long time, which is at least an hour. So I would suggest you all to start really early so that you can finish this on time. You can even start this before your lab to make sure you can boot your Linux successfully. So in this part, as you can see, we'll also include some board specific configuration for compiling the operating system. And this makes sense because we do have a lot of universal source code for operating system, but at the same time, depending on the specifications of each hardware platform, we'll have different ways of how hardware and software communicate with each other. So for this part, you also follow the lab manual, and by this step, you should obtain the kernel image. After obtaining the kernel image, you need to edit the device tree. Why do we need to do this? This is because we are also incorporating the multiply IP. So we'll find this device tree source file and then add an entry for multiply IP. And you should be able to see this address on Vivado. And when you convert the device tree source file into device tree block file, please make sure you're under the right directory. After we've generated the device tree file, we will generate this RAM disk file, which is a temporary file system. And you need to do it under this directory. Okay, after we've generated all 4 files, we copy and paste the files onto the SD card. At the same time, we also use this picocom to see the output of the Linux booting. And please make sure the jumper is on SD card mode. After you press this reset button, you should see the boot sequence, which is being output from the board. And this is the only deliverable in this lab. And please make sure you have a screenshot of the picocom output. And this is all for lab 4.